Good morning, everyone. My name is Dr. Prashant Kumar, Assistant Professor, Department of Chemistry, Vardhaman College of Engineering. Today, I would like to discuss on Engineering Chemistry Laboratory topic determination of chloride content present in the water by Argentometry. Its main purpose is quantitative analysis of especially the halide ions present in the water sample, of course. In addition, we are going to finding the concentration of cyanide, cyanate and thiocyanate anions. Okay. So now the question is, what do you mean by argentometry? In the Latin language, silver is termed as argentum. Since in this analytical technique, we are using silver nitrate as a titrant. So because of that, we are calling this experiment as argentometry. Okay. And now this argentometry is a type of precipitation titration. Okay. It's a precipitation titration. So why we are calling it as precipitation titration? During the progress of chemical reaction, you are going to see a precipitate in the sample. Okay, because of that, your this titration this comes from the precipitation titration. Okay, so now there are three methods to analyze the ions present in the water sample. Okay, so one method is Morse method, Poisson's method, Pollard method. In the current study, we are using Morse method. Because of that, we are calling it as a Morse argentometry. Why you are calling it as Morse argentometry? This method was developed by Carl Friedrich Mohr in 1855. Because of that, we are calling it as Morse argentometry. So, what kind of apparatus we require to perform the experiment? Volumetric flask, conical flask, burette, pipette, beaker. And what kind of chemicals we require to perform the experiment? So, potassium chromate solution act as a external indicator, and silver nitrate solution is act as titrant for this experiment. And now we'll come to the what purpose actually Morse argentometry, most commonly used for finding the concentration of chloride ions in a water sample using the silver nitrate. So it employs what? Potassium chromate as an external indicator, that we have to remember. Now the principle, what is the main principle involved in it? So before principle we'll introduce about actually where you are analyzing the anions present in the water sample. So now the water sample will be analyte solution. So you must take in the conical flask. And what is the precipitating agent here? Silver nitrate. So this is acting as a titrant. You must take it into burette. Okay, you need to fill the silver nitrate solution into the burette. So once you have done it, you need to add a few drops of potassium chromate solution into the conical flask. Now solution color will become yellow. So once you have done it, you need to start titrating against silver nitrate. Okay, what will happen? As the titrant is added, white precipitate is formed. Why? Because silver nitrate, in that silver nitrate, silver ions are reacting with the chloride ions present in the water. Since silver chloride insoluble in water sample, silver chloride is insoluble in water sample and it's observed as a white precipitate in the solution. That's what we are going to see. This is the reaction, chloride ions reacting with silver nitrate and forming the silver chloride and getting byproducts nitrates. Okay, so this is the white precipitate is observed initially. So now once you have completed this, okay, suppose all the chloride ions are consumed from the water. Now what will happen? Okay, who is there? Potassium chromate is there, chromate anions are there. Now silver ions, as the titrant is added, excess of silver ions forms precipitate of red silver chromate. Okay, so means white precipitate due to the formation of AgCl. Once all chloride consumed, it's this Ag plus ions reacting with what? Chromate ion. It forms what? Silver chromate. So because of that, it formed what? It observed in the conical flask red PPT. So now this formation of red PPT is considered as end point. The reaction is completed. Okay, so this is actually the principle involved in the Morse argentometry. But beyond this we are going to talk. So why sir, why white precipitate is formed first compared to red precipitate? Why can't a reverse occur? A reverse process occur means like red precipitate first, white precipitate later. So it is because generally we will explain on the basis of what. So initially it formed a white precipitate, we already know, then it forms a red precipitate. It explained on the basis of what? Solubility product of this AgCl and silver chromate. You can check the solubility product of silver chloride is 1.8 into 10 power of minus 10. Then look at the silver chromate soluble product is 1.1 into 10 power of minus 12. Okay. So now you compare with the solubility product. KSP is higher means more soluble in the water compared to silver chromate. Is the least soluble, KSP is least means it must precipitate first compared to silver chromate, but it's not happening. What is the reason? So because you can look into the stoichiometry, dissociation stoichiometry of silver chloride is 1:1. Dissociation stoichiometry of silver chromate 2:1. So it means that chromate requires 2 silver ions to form the silver chromates. Chloride required only 1 silver. So because of this, the AgCl is first white precipitate is formed first compared to silver chromate. What? It's required higher molarity of silver cations. Okay. Then second reason is you can check affinity towards, means you have the 2 anions chlorides and chromates, but you have the 1 cation Ag plus. The reactivity towards Ag plus is different. Chloride is more reactive as compared to chromate. This is the second reason why white precipitate is formed as compared to silver chromate red precipitate. Okay. So now we'll move into the procedure. Okay. What is the procedure? You have to take 25 ml of water sample, okay, into the 250 ml of conical flask. Add 1 drop of K2CrO4, okay. Then you need to start titrating against the silver nitrate solution. As we know that what will happen when you add silver nitrate into a water sample. Okay. Now we'll move into the end point. What is the end point actually? The initial color of the solution is yellow. End point means the reaction is completed when red precipitate is absorbed in the conical flask. Okay. This is the end point, yellow to reddish brown PPT. So now we'll come to the observation calculations. So we have done what actually? We have taken water sample in the conical flask and we have titrated. Those values is observed here. Until what time we need to titrate? Until we get the 2 concordant values in the experiment. In the first experiment we have done with the tap water. Then you move to calculation part. So I want to find the concentration of chloride present in the water. So during the titration, how much volume is consumed to get the red precipitate? So that's you need to write here, volume of silver nitrate. Then normality of silver nitrate we already known, already given 0.14 normals. Equivalent weight of chloride ion is a 35.5 and volume of water sample which we have taken 25 ml and multiplied with 30,000, then you will get the amount of chloride present in the water sample. Okay, this is with the tap water and again you move with the same titration you do with the distilled water, then you do the same calculation as we have done for tap water. Okay, so then we are going to conclude that see amount of chloride content present in the tap water is this much milligram per liter and amount of chloride content present in the distilled water is this much milligram per liter. So generally we will expect that tap water will have more amount of chloride as compared to distilled water. Okay, and so this is a quantitative analytical technique. It is a type of precipitation titration. Here we are going to find the concentration of chloride present in a water using Argentometry. Okay, so now we will move into the procedure how to perform this experiment to analyze the amount of chloride present in the sample. So now take the conical flask. First take the burette, fill with 50 ml of silver nitrate. Okay. Then take the conical flask, add 25 ml of tap water and few drops of 10% potassium chromate solution indicator. Now you check the solution color. What is it? Yeah. Fill properly, mix properly. So now you see this, the solution color is yellow. Why yellow? Because of the indicator. Okay. Now this is a standard silver nitrate solution already filled. This is the concentration. The concentration of silver nitrate is 0.014 normals. Now titrate against silver nitrate solution. So as we discussed, initial white precipitate has been observed because the formation of silver chloride. As you see, there is some white precipitate is observing, and you will see once consumed all the chloride ions after addition of extra drop of silver nitrate, there is a formation of brick red color. This is the end point. Okay. So initial volume of the burette is 0. Okay. So now the volume is 2.3. So silver nitrate, the volume consumed for the analyte solution is 2.3. How much volume of water sample we have taken? 25 ml. Okay. Initial burette value is 0 and the final reading is 2.2. Exactly 1, 2, 3. 2.3. Okay. The difference will be 2.3 ml. Okay. So this is with what? Tap water. Okay. Now again the same titration repeated until get the what two concordant values. Already know that. The same experiments we are going to repeat. Take the 25 ml with the help of measuring jar, add into the conical flask, and take the few drops of indicator. Okay. Now solution color is unlight solution color is yellow. So now you observe the titration carefully. How many types of precipitates observed in the conical flask? So red brick precipitate is observed. Okay. So now you see the burette reading is around 5 we got. So now burette initial reading is 2.3. We got the 5. So how much volume is 2.7. So we'll take the we have in the second experiment we have repeated and we got the initial value 2.3. Once we titrated ended with the 5 ml in the burette reading. So when we subtracted you got the 2.7 approximate. These two values are nearby, so I am taking the average of these two 2.3 and 2.7. How much it will be? 2.5. We'll get it. So average value is 2.5. So now we'll move into the calculation. Okay. So calculation, the amount of chloride is present in the amount of chloride present in the water sample. Given sample is okay. So volume of AgNO3 is consumed when we titrate against the water sample and normality of the silver nitrate that we already know 0.014 normals and equivalent weight of I am writing here equivalent weight of chloride that will be 35.5. So and multiplied with 1000 and how much volume of water sample we have taken 25 ml volume of water sample we have 25 ml. Now we have to substitute those values what we observed. Volume of AgNO3 is how much 2.5 ml. Okay, and normality of AgNO3 already know 0.014 normals and equivalent weight of chloride is 35.5 and divided by how much volume of water sample we have taken 25 ml into 1000 ml. So we'll see this the calculation. So this will be 49.7. This much amount of chloride present in the tap water. Okay, 49.7 milligram per liter or ppm is present in the water sample. Now the same experiment we can do with the distilled water. So in the place of tap water we will do with the distilled water. Okay, so distilled water means so almost some amounts of ions removed by certain methods, right? Now the same thing repeated with the distilled water 7.5. Okay, so take the 25 ml of distilled water and take into conical flask, add few drops of indicator. You see this? It means that distilled water also has the same color because of the indicator. Now titrate against. This is around now. Initially we will see the white precipitate because of formation of silver chloride. We will see there is a light red precipitate is observed, means the reaction is completed and you will see this it started with 7.5, 7.5 to 8.2, 7.5 to 8.2. So 7.8 to 8.25 means we got only 0.7, right? So now the same experiment will perform until get the concordant values, right? We have to remember this point always. So take the 25 ml of distilled water and add few drops of now titrate against silver nitrate solution. So we got the red precipitate means we reached end point the reaction. Now 8.22 is a 8.9 we got. So exactly we got the point 8.2 to 8.9. So it means this is also 0.7. If you get these kind of this concordant value, this means we got the concordant values, both are same. If you get it, no need to perform further experiment. If you don't get it, you have to perform again until you get the concordant values. Okay. So now we'll move into the calculation. How much amount of chloride ions are present in the distilled water? So volume of silver nitrate is how much volume is consumed? 0.7 and normality is what? 0.014. This is same and equivalence weight is what? 35.5. Now how much volume we have taken? 25 ml and multiply with 1000. So we'll get it around 13.91 milligram per liter. So now we are going to conclude this experiment. So Once we calculate, so the consumed in a silver nitrate volume, how much? 0.7. And what is the normality of silver nitrate? 0.014. And equivalent weight of chloride is 35.5. And how much volume of water we have taken for this experiment? 25 ml and multiplied with 1000. So that how much we got? 13.91 milligram per liter. So now we are going to conclude this experiment. In the tap water case, tap water consists more amount of chloride content as compared to distilled water. Okay, how much we got tap water? Introduction, sir. 7.1 and distilled water this much 13.9. So this is the way we need to conduct the Argentometry titration to find the concentration of chloride ion present in the water. So thank you everyone. We are not just about providing quality education. We believe in all round development. Thank you.